Hello students. In my previous video I talked about reflection and we studied reflection of light in case of a plane mirror. Before moving further we will revise a few important concepts. Reflection of light is bouncing back of light in the same medium on striking the surface of an object. Now whether this object is smooth or it is rough, whether it is flat like a plane mirror or it is curved, it will always follow these two laws of reflection. Now these laws are incident ray, reflected ray, normal. At the point of incidence, all lie along the same plane and angle of incidence is always equal to angle of reflection. In this video we will be studying about spherical mirrors, and spherical mirrors too follow these two laws. First we will see what is a spherical mirror. You must have seen children playing with a rubber ball or a plastic ball, which has rubber or plastic only along the circumference. From inside, these balls are hollow. In the similar way, we have to take a hollow sphere which is made up of glass, or we can say a hollow ball made up of glass which is hollow from inside. So if I cut a piece from this hollow sphere of glass, this much piece, and bring it here and then polish this side with silver, it will behave as a mirror which has a curved surface. So it will be called as a spherical mirror. Or I can cut a part from here and now polish it from the outer surface. I will get now another kind of spherical mirror. Now notice that this is the center of the hollow sphere from which we have made the mirror, and this is the radius of the hollow sphere from which we have made the mirror. This is also the radius. So now the two kinds of mirrors that we have obtained are called as concave mirror and the convex mirror. In concave mirror we have polished the outer surface so that reflection occurs from this bent in surface, and in convex mirror we have polished the inner surface so that reflection occurs from this bulging out surface. Concave mirror is a converging mirror, means when rays of light will fall on it, all of them will converge at one point. While when rays of light will fall on convex mirror, all of them will diverge in different directions. So it is also called as diverging mirror. We will now first understand a few important terms which are related with the spherical mirrors. This is center of curvature, which is represented by capital C. So it is the center of that sphere of glass from which we have made this mirror, and we will define it as center of the hollow sphere of glass of which the mirror is a part. Similarly, radius of curvature represented by capital R. It is the radius of hollow sphere of glass of which the mirror is a part. Now this mirror starts from M till M dash, and this point P is exactly in the center of this mirror and it is called as pole. So pole is the center of the spherical mirror. If I join point M with M dash with a vertical line, that will be the aperture of this mirror. It is also called as the diameter of the reflecting surface. So aperture is that portion of the mirror from which reflection of light actually takes place, and it is the diameter of the reflecting surface. Now next is principal axis. This line is called as principal axis and it is the imaginary line passing through the center of curvature as well as pole of the mirror. So these are the few terms. Now the next important term is principal focus. For locating the principal focus of a spherical mirror, we need to keep two things in mind. First, object should be placed at infinity, means far away. Second, if the object is at infinity, rays will always come parallel to one another. So in case of concave mirror, parallel rays from infinity come and fall on the mirror. As it is a converging mirror, all these rays will meet at one point, and this point will be called as principal focus. In case of convex mirror, parallel rays from infinity will come and fall on the mirror and they will diverge. If we extend these rays backwards, they will appear to come from this point, which will be called as principal focus. Before we see these definitions, first we will learn to draw the principal focus. For that, we will draw principal axis and curved surfaces on this principal axis. Now the total length of this curved surface should be 4 lines, 2 lines above and 2 below the principal axis for both the mirrors. Now we have to polish the outer surface in case of concave mirror so that bent in surface is the reflecting surface. For convex mirror, we will polish the inner surface so that the reflecting surface is the bulging out surface. Parallel rays from infinity are falling on both the mirrors. Show the path of the incident ray with the help of arrows. As concave mirror is converging mirror, so rays after reflection will converge at a point, and in convex mirror, the rays will diverge at a point, diverge from here. And if we extend these rays backwards, they will appear to come from this point, and we need to take care of one thing here, that this complete line and this dotted line should be one straight line. It should be drawn together, half complete and half dotted. So now we will show the path of the reflected rays also with the help of arrows. Now we can define principal focus for both the mirrors. For concave mirror, principal focus is a point on the principal axis at which all the rays which are parallel to the principal axis converge after reflection from the mirror. In case of convex mirror, it is a point on the principal axis from which a beam of light which was initially parallel to the principal axis appeared to diverge from after reflection from the mirror. Last definition or the term associated with the spherical mirrors is focal length. It is the distance between pole and principal focus of the mirror. So this is the pole and this is the principal focus, and this distance is focal length, and for convex mirror this is the focal length. Now we can see the differences between convex and concave mirror once again. For concave mirror we know that bent in surface is the reflecting surface. It is a converging mirror. It has a real focus because rays are actually meeting at this point, and this focus is in front of the mirror. For convex mirror, reflection occurs from the bulging out surface. It is a diverging mirror and it has a virtual focus as the rays are not actually meeting here. And this principal focus lies behind the mirror. Now this is a spherical mirror which has been formed from this hollow sphere of glass, and an incident ray and a reflected ray is shown in this diagram. We want to verify whether these two rays are following the laws of reflection or not. One way to confirm it is we can draw a normal at this point of incidence. But the problem is how to draw normal in a spherical mirror. Had it been a plane mirror, we would have easily drawn an angle of 90 degree at the point of incidence, and that would have been the normal. But how can we draw an angle of 90 degree at this point? It appears little difficult, but actually it is not. As we have studied in maths that if in a circle we want to draw perpendicular at any point in the circumference, then we need to connect that point with the center of the circle. So in this case also, if we connect this point of incidence with the center of curvature, this line will be perpendicular at this point and it will act as the normal. So then we can measure angle of incidence and angle of reflection and find out whether it is obeying the laws of reflection or not. We will now understand how our image is formed in a spherical mirror. For that we need to understand these 3 points. First point is image is formed wherever the rays meet after reflection from the mirror or they appear to meet after reflection. So wherever the rays will meet after reflection, image will be formed there only. And for knowing that where these rays are going to meet, we do not require 1000 or 100 or 10 rays. We need just 2 rays to know where the rays will meet. Wherever the 2 rays will meet, all other rays will also meet at the same point. So we need only 2 rays to know where the image will be formed. Third point is all the reflected rays will follow the laws of reflection. So they will follow a fixed path always, and for some of the rays it is always very easy to identify that fixed path. So we call that fixed path as rules for obtaining images. First we will see these rules for the concave mirror. So there are 4 rules. I have made 4 concave mirrors, principal axis and the paths followed by them. But first of all we need to specify one thing. Let's see this figure. This is the pole and this is the center of curvature. We know the center of the curvature is the center of the sphere from which we have made this mirror. Now where is this F present? F is exactly in the center of P and C. If PC is the radius of curvature, then PF is half of the radius of curvature. So basically we know where P, F and C are located. So now we can see rule number 1. A ray of light which is parallel to the principal axis, after reflection it will always pass through principal focus. Rule 2 is just the opposite of rule 1. A ray of light which is first passing through principal focus, after reflection it will become parallel to the principal axis. Rule 3, a ray of light passing through center of curvature, after reflection it will retrace its path. Now we need to know why will it retrace its path. We just discussed that any line passing through center of curvature will make an angle of 90 degree with the circumference. It means for this incident ray, angle of incidence is 0. So angle of reflection should also be 0. As a result, this ray will retrace its path. Now another thing to notice for rule number 4 is principal axis also passes through center of curvature, means it makes an angle of 90 degree, or it can also be considered as normal. So any incident ray is making angle of incidence, so it will be reflected in such a way that angle of reflection also is same. So these are the 4 rules. Let's see these rules once again. Rule 1. A ray of light which is parallel to the principal axis passes through its focus after reflection from the mirror. Rule 2. A ray of light passing through the focus of a concave mirror becomes parallel to the principal axis after reflection. Rule 3. A ray of light passing through the center of curvature of a concave mirror is reflected back along the same path. Rule 4. A ray of light which is incident at the pole of a concave mirror is reflected back, making the same angle with the principal axis. So these are the 4 rules that we will use to know the characteristics of the images formed by a concave mirror. Let's see the rules for the convex mirror also. It also has 4 rules. So first of all, this is the incident ray which is parallel to the principal axis. When it reflects, it appears to come from principal focus. Rule number 2 is opposite of rule number 1. In this, the incident ray is directed towards the principal focus, and after reflection it becomes parallel to the principal axis. Rule 3, incident ray is directed towards the center of curvature, so after reflection it will retrace its path. Rule number 4, this is the incident ray directed towards the pole and it is making some angle with the principal axis. It will be reflected in such a way that it makes the same angle with the principal axis. So we'll see all the 4 rules. Rule 1. A ray of light which is parallel to the principal axis of the convex mirror appears to come from its principal focus after reflection. Rule 2. A ray of light which is directed towards the principal focus of a convex mirror becomes parallel to the principal axis after reflection. Rule 3. A ray of light directed towards the center of curvature of a convex mirror is reflected along the same path. Rule 4. A ray of light that is incident at the pole making an angle with the principal axis is reflected in such a way that it makes same angle with the principal axis. So these are the rules for the convex mirror. That's all for now. In my next video, we will learn about the formation of images in case of spherical mirrors.